I'm currently working on building a full custom trunk that features two 12-inch subwoofers, and I now need to create the beauty panel shapes that we designed in the previous videos. All I need to do is press start on my CNC machine and out pops the finished parts. Right? Nope, there is much more to it than just that. After all, my hobbyist grade CNC machine is not large enough to make the parts that I need. How did I deal with that challenge, and what is the workflow to go from a designed part on the computer to a shaped part ready for more detail work? Before we get started, a quick thank you to our show sponsor, New Concepts. If you're installing an aftermarket car audio system, you're going to need a way to connect the aftermarket wiring to your vehicle's battery, and a great solution for this is the New Concepts Ultimate Battery Terminal. With this terminal, we can add new aftermarket wiring and simply relocate our factory connection, avoiding cutting or modifying the factory connector. The Ultimate Battery Terminal gives us a lot of different connection options. If you'd like to learn more and see a full overview video that I did on this, check out the links down in the video description. Previously on this project, we came up with this 3D design of all of our beauty panels for our custom subwoofer enclosure. Now, since we've done all the work to come up with all of these shapes, we of course have the CAD data that we can export to cut on the CNC machine. I've hidden the 3D scan data and the subwoofer enclosure itself along with the amplifier rack, and you can see the 4 pieces that we're going to need to make in this video. When it comes to exporting our CAD data, as an example, let's look at this piece here, which I call the beauty board or the main baffle board. I basically want to capture the data here in 2D, so what I've done is I've made a sketch and I've projected all the different outside parts of these shapes along with all of the cutout through holes and a line that I've offset from the center of this piece by 1 inch. Depending on our CNC software, we're going to want to export this information as a DXF or SVG type file. In this case, for the CNC machine that I'm using, we need to bring in this file as an SVG type file, and I've done so, as you can see here on screen. Once I have this 2-dimensional data on screen, I need to tell the machine how to interpret it. We'll start with this hole cut out here. I know that I want to cut on the inside of this shape path. If I were to do a cut on shape path, what that means is the CNC router bit is going to be centered on my cut line. I want the CNC bit to be offset to the inside. That way my final cut is the diameter dimension that I'm looking for. So let's change this back to cut inside shape path. In contrast, this line here is for the outside of the shape. So in this case, I want to cut outside of the shape path. Now next, you may notice these little yellow marks here, and these are tabs that I want to have added to the part when the machine is going through its cutting process. So I've selected to use tabs, and I can control the length of the tab and the height, or the thickness, if you will, of the tab, along with the quantity of how many there are. You guys are going to see more what these tabs do during the cutting process of this project. Finally, all these black dots are hole locations, and I've actually changed the size of these to be 3/8 of an inch. All of these cuts are going to cut all the way through the material, and the reason I changed these holes to be 3/8 of an inch is because the router bit that I'm going to be using is actually a larger diameter than what I need the final hole size on these holes to be. So we're going to be transferring these holes later in the project to our final piece. This will make more sense as we go through the cutting process. If you're wondering why I added that 1 inch offset line earlier from the center of my board here, that's because if I were to make this board a full piece, it's going to be larger than the cutting area of my CNC machine. You can get a rough idea for the cutting area of my CNC machine by looking at this light blue color. Obviously, this piece, if it was doubled over, is going to extend outside of that. So instead, what we need to do as part of this process to use my hobbyist grade machine is we're going to need to cut just half of the part. And the reason that I extended this by 1 inch over the half is so that I could still have these hole locations be perfect on that centered point. If I were to make this particular piece exactly half and not have that 1 inch offset, I wouldn't be able to precisely locate each of these cutout holes. Now we're keeping things really simple here, but here in this software, we're also going to tell it that we're using a 1/4 inch 2-flute spiral upcut bit. And in this case, on this software here, that's going to give us some recommendations for the feed rate, the plunge rate, and how far we should go on depth per pass. I've used this bit extensively, so I know that I can do some manual changes to the settings here. I typically go a little bit faster on the feed rate and the plunge rate, and I go a little bit deeper on the depth per pass. If we do a simulated run here, we can see that in order to make this cut is going to take us about 13 minutes, and we can speed up the real-time speed here to get an idea how it's going to step through and do each of these cuts. So I repeat this process for all of the shapes that I need for this project. We again have the baffle piece here. We have our side profiles that are going to match up with the sides of the trunk. We have our inner template piece. This is going to be our insert piece. Again, in this case, this is a half piece because the full-size piece would be too large for the cut area. And finally, we have this outer piece. Again, this is a half piece. Let's head on out to the shop. Now that we have each of the cuts planned out in the software, I do need to cut the raw material for each of these pieces. So I'm going to look up here for each of these pieces and record these values. So I've got all my boards cut here, and the first piece I'm going to cut on the CNC router is the baffle piece. I'm calling it the baffle piece, but that's that outer piece that's going to go onto the enclosure first in front of the subwoofers. To get started with our cutting process, we need a way to secure our workpiece to the CNC router. I prefer to use double-sided template tape. It's really easy and quick to apply, and you don't have to mess around with any clamps. And since there's nothing up above the workpiece here, you don't have to worry about potentially running into one of your clamps with the machine. After making sure that the router table surface is free of dust, I'm going to stick this in place, and I'm going to carefully line up the lower left corner so that it's lined up with the XY0. Now, software is of course different from machine to machine, but on this particular software here, first of all, we need to confirm the material thickness. That way it knows how far down it needs to go into the material. In this case, we're using 1/2 inch MDF. This step here is more of just a safety check to confirm that everything is secure. We'll want to make sure we confirm our bit, which in this case here, I'm using this 1/4 inch 2-flute spiral bit. And now we need to start setting up our work zero. We're going to start with doing our Z offset. First, I need to jog the machine over the center of the workpiece. And the software is going to walk me through each of these steps, but I'm going to show you guys down on the table. On this machine, this is our Z axis probe. And basically all this is doing is we're going to run a small electrical current through the router bit, and it's going to be able to detect when the router bit touches this pad. So I'm going to plug the probe into the machine. I'll put this clamp around the collet, and I'm going to put the pad down underneath the bit. And once I start the probing sequence, the machine is going to lower until it makes contact with the pad. I've used the calipers to measure the exact thickness of this and input it into the software. That's not something that you have to do every time. You only have to do it once when you initially set up the use of this probe. But since the software knows the thickness of that pad, it knows exactly how far down it has to go before it's going to touch the top surface of the material. Next, the machine needs to know where it is in the X and in the Y plane. So I'll use the keyboard to jog the machine over to that location, and it's not critical to be absolutely perfect here, but we do want to try to get as close as we can. Now keep in mind, having to use the Z axis probe and having to manually jog over here for an XY0, those are things that are more common with these lower end machines. As you get the higher end machines, these things become a lot more efficient and easy to do. But nevertheless, we're almost ready to start running our program here. Just a few more checklist items. We can raise the bit so that we can attach the dust shoe. We'll make sure that we attach the dust shoe, and in this case, I need to manually turn on the spindle. That basically means just turning on the router. But once we've done that, we can officially hit carve. Let's start the time lapse. Now that the cut is done, I'll jog the machine out of the way and clean up some of this residual dust and then pop the piece off of the work surface. Now don't forget, the reason that everything stayed in place and stayed attached together once I popped this off is because of all of these tabs that we added in the software. The tabs make it so that I didn't have to apply the template tape everywhere to hold this piece in place. I prefer using these tabs instead of a bunch of template tape because if you have to go all the way through the material to make your cut and you're starting to chew into that template tape, it does have a tendency to gum up the bit. So for that reason, that's why I like having the template tape around the outside where I know I'm not going to hit it. And removing these tabs is really simple and easy. I'm going to show you guys that in a second. But again, this is something that's a little bit different about a lower end machine. A high end machine, you would have something like a vacuum table that literally uses vacuum pressure to suck these pieces down and keep them in place, even if you don't have the tabs. But even on those machines, sometimes you do want to keep the tabs if you have a smaller cutout where it's not going to pull down enough vacuum. It's all very application dependent. So to remove the tabs is simple enough. I'm just going to use a razor blade to cut them, and then I'm going to go over to the router table. Here I have a 1/4 inch spiral flush trim bit, so it has those bearings that are going to ride against the finished edge and remove the tab below. So here we have it, guys. One cutting process down, 3 more to go. Cue up the time lapse. If I could just jump in real quick here, I just want to say thank you guys so much for tuning in and watching. I truly appreciate it. If you are new here, I would love to have you as a subscriber. My name is Mark, and here on this channel, we learn together how to master car audio and how to design, build, and install our dream car audio system. Let's get back to it. So now that we have everything cut out, with these pieces here that are the half pieces, I need to transfer those to a larger board. So in the meantime, off camera, I've used the table saw to cut these overall size pieces. So the first piece that I want to combine into one larger piece is this one here. Now the trick here is, since I know the bottom of this piece is flat and I know that this plane is parallel to this plane when I did my design, that means that on the table saw, I can just cut my new board to that exact same dimension. The reason that's beneficial when you're using this strategy of having a lower cost CNC machine to make larger parts is, this is going to have some degree of flex to it when I go to stick it to the board to copy it. And the same goes for this piece. It has a small amount of flex. By doing it this way, cutting our new board to that exact same dimension, I can line up the edges here perfectly, and I'm going to be able to perfectly transfer this piece. I'll start this process with carefully tracing out the profile and marking the center line, and then flipping this shape over and doing the same. Now I'm going to use a jigsaw to rough cut this piece, saving about 1/8 inch of material. With our larger piece rough cut, I can now apply template tape, remove that backing paper, and secure our template piece. Now you'll notice that I also added this straight template, and the reason for that is I don't want to make a mistake and accidentally go around this edge with the flush trim bit when I'm copying this. So this gives me a continuation of the profile. So now we can take this assembly over to the router table, and again, we're using a 1/4 inch spiral flush trim bit to completely copy the shape. All right, so we've got 1/2 copied and perfectly matched to our shape. Now this is a critical step. Remember our hole locations that we made on the CNC machine, we want to transfer those exact locations to our new part. So here I'm going to be using a transfer punch, but I'll talk more about this process in a little bit. Once those hole locations are transferred, we'll flip this piece over and repeat the process on the router. So now guys, we have our finished full piece. As you can imagine, the steps are exactly the same for doing this inside piece, so I'm going to do that on the router off camera. So here it is, now that we have all of the pieces made. Check out how this is coming together. This is going to look sweet. Now remember, throughout this process, we transferred all of the center holes for those hole locations. Let's go over and drill those to the correct size. Now, when we made our parts on the CNC machine, remember that I oversized these holes to 3/8 of an inch. That way I could use my 1/4 inch bit. I need my through hole for my fasteners to be smaller than 1/4 of an inch. I need it to be 3/16 of an inch, which I have loaded up in the drill right here. What I'm going to do is I'm going to take a 3/8 inch transfer punch. You can see that this fits really nice and snug in that hole that we made on the CNC machine. This has a small little point at the tip that is perfectly centered, so we're going to be able to transfer the center of that hole location. I'll give this a couple of taps with the hammer, which allows me to perfectly center my drill bit. And if you're wondering what that odd shaped piece of metal is with all the holes in it, that allows me to perfectly drill square into the piece and transfer this 3/16 inch hole to my new piece down below. Now that all the holes are added, you can get an idea how this is going to go together. First, I'll be attaching these two wing pieces to the enclosure, and then the baffle piece and this outer piece actually attach to each other and are attached to the enclosure as an assembly. Finally, this inner trim ring is going to cover the remainder of the hardware. So in the next step of the build process, we need to do some detail work to all of these pieces. We want to add the hex pattern here. We need to do some chamfers and some roundovers to soften some of these hard edges. And we need to apply threaded inserts into the subwoofer enclosure itself so that each of these screws has a location to mount. To see the next steps and all of the previous videos for this project, be sure to check out the related videos here on screen. Don't forget, next time you need to make aftermarket connections to your vehicle's battery, be sure to check out the ultimate battery terminal from our show sponsor, New Concepts. You can learn more at the links down in the video description. A big thanks to them, along with Jerry and the rest of the Patreon membership team, for making these videos possible, and thank you for tuning in and watching.